very good day. I would like to wish to our lecturer, Dr. Muhammad Zaini bin Yunos. My name is Jacquelyne and Boudeville from Section 6, AD140225 for the subject BDA24202 Computer Programming. We are assigned to write a C program to solve engineering problems based on two scopes, which are the solid mechanics and material science. From these two scopes, I have chosen solid mechanics. Solid mechanics. Solid mechanics is a big branch of study, and under solid mechanics we have deformation of materials. And based on this scope, deformation of materials, there are also deflection of beams. Hence, I will do the study under this scope of deflection of beams. This is my case for deflection of beams. I am choosing the case of a beam supported both ends with a fixed support and as well as loading at the middle of the beam, which is the concentrated loading at the middle of the beam. As you can see, this beam is fixed at both ends, and W is the load applied on the beam. The whole length is noted as L, and at the center, the length is divided into 2. So from the center to the end is L over 2. And the distance between the center to the end of the beam is denoted as X. However, in this particular project, I would like to investigate more on not only the maximum deflection but also the deflections of one particular point and the deflections of those points moving towards the maximum deflection. Hence, we are going to have increments from X and X plus plus towards the maximum deflection, which is at L over 2. This is the flowchart created for my program. As you can see, there are 4 sections in this flowchart. Moving forward to the first part. In the first part, we are going to identify the type of cross-section of beams, which are either circle or square. And from here, we are able to identify the moment of inertia I, which will be later used in the equation to find the deflection of beams. Moving on to the second part, we will be finding the moment at both ends of the beams, the reaction at both ends of the beams, and the distance where maximum deflection occurs. And then, moving on to the third section. In this section, we are able to find the deflection of X and the deflection of X with increment until the condition doesn't allow. For this section, given that we were to choose an X value, and from the X value, we will be finding the deflection. In the deflection, if it satisfies the conditions, it will print the deflection at the particular point before it loops back, and with increment for the X, which is the deflection points, as well as iteration, it will continue to loop on until it no longer satisfies the condition, which is X is between 0 and big X, which is the maximum deflection where it occurs. Hence, and then we will move on to the final section, which is to find the maximum deflection. After ending from the previous loop, X would be changed to X is equals to big X, which is L over 2. And by substituting this X into the equation, we will get the maximum deflection. Hence, it would end this program. That's all from me for this project and presentation. Thank you.